All right, folks, welcome to Yak Math Videos for your STAT 1300 Hypothesis Testing Quiz Review video, folks. Today we are brought to you by Litchfield, sponsors of Chinatown Coffee Espresso, Ruby Tuesday, corporate sponsors of Cliff Bar, Laura Bar, and in-house we have Ultra Running, the new Ultra Vanish, 4.2 ounces, run almost as fast as Mr. Yak in your new Ultra Vanish running shoe. Some folks claim that we don't have, first off, zero drop technology. We don't have real sponsors, but as my dear friend and also sponsor, T Swift, said, haters are going to hate. Anyway, folks, I have 10 of these answers for you. We did talk about 1 and 2 in class. We're going to make this quick. In every single question on your quiz Friday, you need to state the null hypothesis and the alternate hypothesis. Folks, the alternate clearly says greater than 35. We're talking about a mean here, so that is the claim. Greater than. Remember, the alternate hypothesis always has the inequality. That means the null hypothesis is the mu is less than or equal to 35. That's going to earn you a point. Then you take that and the fact that it is greater than, that's a right-tailed test. You draw your rejection region. That's another point. 1% means alpha is 0.01. 0.01, if you go, remember, to your z-table, that means 0.99 is to the left. That is a z-score of 2.33. That's where your rejection region begins. 1% either left or right tail, that's plus or minus 2.33. Then you compute the test stat using that formula, which I give you. All right, so your test stats then is going to be 1.94. 1.94 is to the left of this. To the right of this is the rejection region, what I shaded in there. So this is not in the rejection region. That means we don't reject HO. So we're saying HO is pretty good. That means this is not good, so the claim looks bad. That's everything you need to do to answer these questions Friday. You're going to have 10 questions on your quiz. The quiz is ready to go. An exit poll of 1,000 randomly selected voters found that 515 favored candidate A. Is this race too close to call? You could set this up 2 different ways and you'd be all right. Too close to call means you know that it's 50-50. So you can evaluate whether it's not 50-50. Or you could say this. All right, you could say that it is equal to or less than or equal to 0.5, and you can evaluate whether or not this candidate is actually receiving more than 50%, so greater than 0.5. Doesn't matter what you do. Again, that would change your rejection region. If we had a two-tailed test that alpha is 0.05, two tails mean 0.025 would be there, 0.025 would be there, 95% would be in the middle. That's your 95% confidence z-score. All right, and then here, if it was a right-tailed test, if alpha is 0.05 to the right, that's a z-score there of 1.645. Folks, your test stat, again, this is the formula for a population proportion. All right, p hat is the sample proportion, all right, which is simply 515 over 1,000. Okay, that's 0.515. Then you subtract the proposed tie, is it too close to call, 50-50. You get a z-score of 0.95, which is solidly in the region of not rejection. Okay, you're not rejecting HO, so HO looks good. That means the race is too close to call. It's looking 50-50. All right, folks, let's take a look here at number 4. We did not talk about 4 in class, I don't believe. Badco produces your typical consumer battery. Their batteries claim to last at least 100. So lasting at least 100, that's greater than or equal to. That means the alternate hypothesis is going to be less than 100. And that's what it says. You decide to conduct a test to see if it's actually less than 100. So that's the claim. This is a mu, so we're using that formula. Okay, alpha is 0.01. All right, this is a left tail test because it's less than. So your rejection region begins at negative 2.33. Let's compute the test stat. X bar is 97.89. Standard deviation is that. Your sample size is 90. The proposed mean is 100. Your test stat is negative 2.10, which does not fall in the region of rejection. It's very close, but it doesn't fall in the rejection region. So it's not in the rejection region. You don't reject HO, so that means you're saying HO could be good, so the claim looks bad. All right, that's very close. In fact, if alpha was 0.05, it would be in the rejection region, but you're using a 1% level of significance, so you fail to reject your null hypothesis. Kathy works for Mesa Air Pollution Study at University, I think it was Wisconsin this question came from. All right, this is a proportion question. Nationally, 40% of adults suffer from this. She believes that people in high pollution areas are going to suffer at a greater rate. So greater than 0.4 is the claim. That means the null hypothesis is less than or equal to 0.4. Your test stat, 270 over 600, is exactly 0.45. You round those to the nearest 3 decimals if you have to on Friday. Again, you're given your formula. You do p hat minus p divided by the square root of p times 1 minus p all over your sample size. You can take your time finding that. It's exactly 0.05 and 0.02. Those were not rounded, folks. Do not round that denominator. Okay, just simply do, 0.05 divided by answer. Your z-score is exactly 2.50. That test stat is in the rejection region. We reject HO. So if we reject this, we're saying that this looks good, the claim looks good. All right. We did this one in class. Number 6. Looks like 7 and 8. We did 7 in class for sure. I'm going to do 8s. Definitely hint, wink, wink on 8s. Number 9, the diameter of a spindle in a small motor is supposed to be exactly 5. Okay, that's what the claim is. Do you have enough evidence to conclude that the mean is not 5? So the alternate hypothesis is it not being 5, and that's the claim. You're looking for evidence to conclude whether or not that's true. And the null hypothesis, HO, is the mean is 5. You're doing 2 hypothesis tests, 1%, 5%. And on your quiz, folks, you always just do 1. I only give you 1 alpha on your quiz to make it a little bit shorter. X bar is 4.951. Standard deviation is 0.81. 60 is your sample size. Your test stat, negative 2.11. Your rejection region for the 1%, you're dividing in 2, folks. That means 005 would be there. If you look up 005 in your Z table area, that's the one that's kind of weird, negative 2.576, positive 2.576. The test stat is not in the rejection region. We fail to reject HO. That means we're saying it's good, so the claim looks bad. For the 5% level, though, our test stat is in the rejection region. So at alpha is 0.05, we reject HO and say the claim looks good. So it depends on our level of significance. In the real world, we would probably, we would notice that at 1% we fail to reject HO, so the claim doesn't look good. So especially if I was the company, I would focus in on the 1% one. Researcher claims 15% of adults in the U.S. are allergic to trees. You think that more than 15%. So P is greater than 0.15 is the claim. So the null is less than or equal to 0.15. P hat is 18 divided by 95, which is 0.189. Compute the test stats. All right, 1.06. That lies. This is a 0.05. Alpha is 0.05, or 5% level. So that means 1 is going to be right tail test. 1.645 begins your rejection region. 1.06 is right there. It's outside. You fail to reject HO. So HO looks good, so the claim looks bad. And folks, we're rolling. The next one we're going to talk about here is 14 in a group of 407 University of Pittsburgh students. 42 are left-handed. Is this significantly lower than the proportion of all Americans who are left-handed? So is it lower than? When we say significantly, is it statistically significant? All right, so the claim is less than 0.12. The null hypothesis would be greater than or equal to 0.12. Your test stat is 0.103. or not your test stat, your sample proportion, sorry. Compute the test stat to get negative 1.06. This is a left-tailed test because it's less than. Alpha is 0.05, so your rejection region begins at negative 1.645. Your test stat is not in the rejection region. You do not reject the null hypothesis. You fail to reject it, basically. So the null hypothesis looks good, so that means the claim looks bad. All right, we talked about 6 in class. Know how to use that calculadora. 18, folks. Standard treatment for a disease works in 0.65, basically 65.7% of all patients. A new treatment is proposed, and I forgot to write this in, but you're going to use the new treatment if it beats the old treatment. So you want to beat the old treatment. You want it to be greater than 0.675. Your sample, proportion is simply 76 divided by 100, 0.76. Your test stat is 1.81. So at 1% and 5%, so at alpha is 0.01, two-tailed test, 1.81 would be to the left, so you fail to reject HO, so the claim looks bad. But at alpha is 0.05, you reject HO and say the claim is good. So if you're the person that is developing this new treatment, you can use alpha as 0.05 to say that, hey, this looks good. Let's go with the treatments. All right. And lastly, folks, 19 and 20 here. We're going to try to do these pretty quick. Regional store claims to average 100 grand a week in sales. You want to test the claim that they average at least 100,000. Greater than or equal to 100,000 is the claim, so the alternate would be less than 100, and their sample was less than that. So their test stat negative 3.44. Both of these would be left-tail tests, right? Less than. And alpha is 0.01. That's the score, that z-score that begins the rejection region. Alpha is 0.05. That's the z-score. The test stat lies in both rejection regions. So you're going to reject HO in both. So the claim looks bad because it was HO. Local University's freshman class has an historical ACT average of 25.6. College of Science, though, we think that their ACT scores are a little bit higher. So you sample 148 of them. That's their average ACT score. That's the standard deviation. So we think they're better than the average of 25.6. That's the claim. That's the alternate hypothesis because it's an inequality. That's a right-tailed test. If alpha is 0.05, then the rejection region begins at 1.645. Your test stat is 5.61. It's solidly in the rejection region. You reject HO, so the claim that they do a better job looks good. Folks, this is Yak Math Videos signing out.